Good morning, Nikki. Good morning, Tim. Good evening, actually. Good evening to you.
Good evening. Good morning.
Good morning.
Good evening, everyone.
A very warm welcome to the Consul General Thailand, Mr. Nitirush Prasad, who has just joined us. Most welcome to you, sir. Can we, Tim, can we start?
I'm not sure if you want a little more time for people to assemble. Again, we welcome everybody for attending this event and coming on. So I think maybe a couple minutes more. What do you think, Nikki? I think we should a little more time.
Yeah, let's wait a few more minutes and then
a couple more minutes, yeah, because it's a lot of people and it's a great distance. Again, welcome everybody.
Sure. Tim, we have 48 participants now. The numbers are steadily increasing.
That's great. Awesome. I have a very noisy cat here, so I'm just going to mute for a while.
We see the Consul General of Thailand, Mr. Nitirush Prasad, attending this webinar, who will be shortly inaugurating this webinar. Most welcome to you, sir, Mr. Nitirush Prasad.
Yes, good morning.
Very good morning. Tim, we have 57 participants. Can we start?
It's your show, DB. So if you want to start, you're welcome to start. I think it'd be wonderful.
Sure. Thank you. Thank you for that. Greetings to you all from Explore the Space. Explore the Space, an NGO promoting space education across geographies in association with ETS-Elcon Precision LLC, a metal finishing company based in San Jose, USA, and a direct supplier to NASA, is pleased to bring you this international webinar on future of space technology and exploration. The webinar series has the following three objectives: to encourage the global youth to pursue space education, to facilitate industry institution linkages in space and allied industries, and to emphasize on global space cooperation. After two very successful editions early this year, in June 2021 and September 2021, today we have the third edition of the webinar series. And this edition will be on microsatellites, manufacturing and operating technologies and challenges. We welcome for today's webinar Consul General, Royal Thailand Consulate, Chennai, His Excellency Mr. Nitirush Prasad, who has kindly consented to inaugurate the webinar. We welcome Mr. Tim Dyer, President, ETS-Elcon Precision LLC, the American company with whom Explore the Space is partnering in doing this series of webinars. We welcome Ms. Rebecca Salcedo, Process Engineer, and Ms. Nikki Du, Data Analyst, ETS-Elcon Precision LLC, USA. Ladies and gentlemen, the first edition of the webinar in June 2021 was on advanced materials for launch vehicles by Mr. Tim Dyer. Now, we all know that space vehicles are expected to travel enormous distances over long periods of time without an opportunity for maintenance, refueling, or repair, and such space vehicles are subjected to temperature spikes, gravity variations, radiation, pressure, impacts, and vibration. Mr. Tim Dyer's fantastic presentation on 25th June helped us to understand the importance of the manufacturing process for material and components to be used in outer space and the amount of diligence and patience that the process demands. Moving on, the second edition of the webinar in September 2021 was on NASA's Artemis mission and humanity's return to moon. It had Dr. Jaideep Mukherjee, Director, Florida Space Grant Consortium, Florida, USA, as the main speaker. The Artemis program is a United States-led international human spaceflight program. Its primary goal is to return humans to the moon, specifically to the lunar South Pole by 2025. Dr. Jaideep spoke about space exploration, NASA's Artemis program, and problems and challenges for future lunar explorers. Friends, after two highly interesting webinars, today we have the third edition. This particular topic is on microsatellites. Satellite imaging has revolutionized our knowledge of the Earth, with detailed images of nearly every street corner readily available. In the last 10 years or so, there has been a great revolution going on in the miniaturization of satellites. Advanced electronics and sensors are enabling this revolution, where work that was done by satellites weighing 1,000 kilograms is now done by satellites that are the fraction of the weight and is the size of a loaf of a bread. That is the kind of miniaturization that has been happening now. Now, these faster and cheaper microsatellites are changing the Earth observation industry, as there is a growing market for economic intelligence, military intelligence, unmanned aerial vehicles, etc. The demand is only growing by the day. On the opportunities available in space, now space and allied industries offer a lot of opportunities for the youth of today. It could be the ground systems, where you have opportunities to build launch vehicles, support systems, and subsystems. We move on to other opportunities in additive manufacturing, artificial intelligence, information and communications technology, optics, space medicine, space food, virtual reality, remote sensing, Python language. Now, these are some of the skills and technologies that are in demand. The emerging scenario demands that we all work together to build an inspiring workforce for the space industry of the future. How can this be done? Well, we can support STEM and space-related initiatives in educational institutions, develop programs to enable students and young professionals to gain real-world space-related educational and professional experiences, attract international space experts into the space education and industrial sectors, inspire the next generation through the fascinating aspects of space, and showcase the diverse career paths that the space sector and space professionals are working internationally. I'm sure this is a very good agenda for preparing the future workforce for the space industry. Ladies and gentlemen, I would also like to take this opportunity to invite the audience to participate in Space Tech Expo, the largest and most attractive space industry exhibition happening in California, USA in May 2022. Space technology companies from the entire gamut, launch vehicles, satellites, subsystems, components, materials for space industry will be showcasing their products and technologies. We will be organizing a delegation to participate in Space Tech Expo California of companies and institutions from different geographies. About the audience for this webinar, we have science and engineering college students as well as faculty members from different parts of India, United States of America, Uganda, United Arab Emirates. And it is quite interesting to see that their interest varies from black holes, building nanosatellites, deep space faring, solar energy for spacecraft, etc., etc. Friends, this is exactly the mission of this webinar brought to you by Elcon Precision LLC and Explore the Space. as the purpose of the panel is to inspire young people to target a career in making space devices and machines and explore the space. Friends, we have a very interesting and very important gentleman to inaugurate today's webinar. Thailand in South Asia is a great country that's making remarkable progress and showing great interest with an upcoming space industry. The Thai Space Consortium project is a project of the government of Thailand, where it is working with partners to produce satellites and boost the country's space capabilities. I have pleasure in presenting you the Consul General of Royal Consulate of Thailand, Chennai, Mr. Nitirouche Phone Prasad. Mr. Nitirouche Phone Prasad is the Consul General of Thailand in Chennai, India since June 2019. Mr. Nitirouche has been serving as a career diplomat with the Ministry of Foreign Affairs of Thailand since 1986. During the past 33 years of service, he had been assigned to work in different offices at home and abroad. Mr. Nitirouche had been in overseas posting in the Philippines, Germany, Malaysia, and Peru. During his tenure in the department, he was awarded with the 2018 Outstanding Performance Thai Civil Servant. In 2020, he was awarded with Royal Decoration of Knight Grand Cross of the Most Noble Order of the Crown of Thailand. Mr. Nitirouche received his Bachelor of Arts in Political Science from Chulalongkorn University in Thailand and Master of Arts in International Affairs from the Norman Paterson School in Canada. Mr. Nitirouche has successfully completed his executive education in the United States, including the Executive Development Program from the Wharton School, University of Pennsylvania in 2017, and the Managers Government Program from the John F. Kennedy School of Government, Harvard University in 2019. I have pleasure in requesting Consul General Mr. Nitirouche Phone Prasad for his inaugural address, please. Over to you, Consul General, sir. Could you please unmute?
Yeah. Good morning, everyone. Distinguished guests, ladies and gentlemen. It gives me an immense pleasure to inaugurate the third edition of the webinar series on future space technology and exploration, organized by the Explore the Space, an international organization working on space education, and ETS-Elcon Precision, an American aerospace company that does business directly with NASA. I'm glad to note that the keynote speaker today, Mr. Tim Dyer, Managing Director of ETS-Elcon Precision, is going to speak about microsatellites, manufacturing and operational technologies and challenges. In 2020, there was an estimated total of over 3,000 active satellites orbiting the Earth, and increased from 2,298 active satellites in 2019. So microsatellites are only going to increase this number further. We are all eagerly looking forward for the presentation of Mr. Tim Dyer and his team. Our compliments to Mr. Venkatagiri and his team at Explore the Space for their efforts in putting together this program. Ladies and gentlemen, international cooperation in space exploration has the potential to provide significant benefits to all participants, particularly if managed well. Benefits in the form of monetary efficiency, programmatic and political sustainability, and workforce stability will accrue to those partners who choose to approach space exploration as a mutually beneficial endeavor. Having said that, I would like to give you a brief on this Thai space technology. Thailand first mobilized space information for the country's management of its natural resources, development of science and technology, and nurturing national and domestic security strategies. In 1971, Thailand collaborated with NASA's Earth Resource Satellite 1 to establish ground station for aggregating data, making it first of its kind in Southeast Asia. IP-STAR or THAICOM 4, Thailand's fourth communication satellite built by the US, offers a host of broadband services for Australia and other Asia Pacific region. ETS, or Thailand Earth Observation Satellite, was Thailand's first Earth observation satellite built by the agency called Geoinformatics and Space Technology Development Agency, or in short, GISDA, in partnership with France for remote sensing and monitoring agricultural land, flood situations, natural resources management, and national security and military use. The other satellites developed by Thailand are ETS-2, NACSat, and amateur radio JISAT-1. A pilot satellite named TSC Pathfinder, the first to be made by Thais, is expected to be launched in 2023 to survey Earth's natural resources. It is among 5 small satellites being developed by the Ministry of Higher Education, Science, Research and Innovation in its 2021 to 2027 Space Technology Program. Following TSC Pathfinder launch in 2023, more satellites will be launched to survey the Earth over the next 4 years to trace dual system technology, to test low frequency X-band signals, and lastly, by 2027, to put a satellite in the moon's orbit. The Thai Ministry of Higher Education and 12 other partners have signed an agreement to work together on space technology research in project involving 5 universities and space technology related agencies. Key research area will be space engineering development, application, research and development, and educational and industrial support. Furthermore, the National Innovation Agency, or NIA, of Thailand has recently launched Space Economy Startup Development Program, or Space Economy Lifting Off, in partnership with Thai Space Consortium to strengthen Thai space industry and groom talents to become experts in space technology. This includes an opportunity to utilize space technology to support national development. The program aims to incubate and provide commercialization opportunities for deep tech startups, which address the needs for space economy. This is to ensure startups' products and services could be leveraged and expanded locally and internationally. Ladies and gentlemen, Thailand has always recognized that space has dimension beyond national consideration, which can only be addressed along with international partners. The scope of cooperation among countries in space technology is multifaceted. While exploratory missions beyond the Earth are the natural candidates for such cooperative efforts, there are many other themes such as climate change impact on Earth, space science and planetary exploration that are of keen interest to international cooperation because of their global impact. On this note, I wish the organizer of this program all success as they do this series of webinars to promote space education among the youth of the world. Thank you.
Thank you. Thank you very much, Consul General, sir. That is a very inspiring inaugural address for us. Thank you very much. We would request you to stay through the proceedings and give your very valuable suggestions as we move on. Tim, may I request for your presentation now?
Yeah, that's fine. And thank you, Your Excellency, Mr. Nishan Ruj, for your talk, your introduction. I visited Thailand with my family 2 years ago, and I think it was most beautiful. We were Koh Samui, and it is the most beautiful country. It's amazing that you're actually going outside such a beautiful place to explore space. But again, it's wonderful, beautiful place, and I would recommend anyone if the opportunity to visit. It's a great place to go. Just such a wonderful country. Let me go ahead and put my screen on here for display here, and let's get this going. And is this, hold on, is this my correct? Yeah, here we are. Let's start here.
Yeah.
That's good, yeah. And this talk is Elcon Precision. We're a small company in San Jose, California, but we do a lot of great things. And this is a momentous night for the company. And I want to say that Tonight, the NASA DART mission launches from Vandenberg Air Force Base. It's the first interplanetary defense mission that uses a device that the launch systems were provided by Elcon Precision. In addition, the ion engine components, Rebecca, who's in the audience, who's participating, well, she actually was part of that construction of that ion engine, which is the first planetary defense mission of mankind. And it launches at 10:30 p.m. tonight, if it's on schedule, from Vandenberg Air Force Base, a very big day in space. So DV has selected a wonderful day to have an event because of it's such a historic day, at least for us as a collaboration of countries to to launch an interplanetary mission. And what's great about space is it unites everybody. It really is apolitical because we all have to work together as countries and scientists and engineers on our mission to better understand who we are and where we come from and where we're going, and also to protect us as a planet so that future generations of young people are able to live such a wonderful life that we do now. So again, you know, this is a momentous event. So this talk is on precision components for microsatellites and nanosatellites. And I remember as a child watching satellites flying across the sky on night times in California. And so these are actually much smaller than ones that we used to see when I was younger. Let's see if I can advance the slides here. Elcon is a small company. We're 53 people in Silicon Valley. I'm not going to talk much about it, but you can see us on the web. We have a website that's accessible so you can understand who we are, but we're a group of engineers and we're fabrication experts who work with components for medical and space applications. And again, it's a small Silicon Valley company started in 1967. Our mission is really to apply Silicon Valley engineering to solve problems. And we provide high quality manufacturable solutions. We build long-term partnerships with clients like NASA or SpaceX, Momentus Aerospace to provide great products. But really our fundamental mission is a team of material scientists and fabrication experts who want to assure success in critical applications that directly contribute to the preservation and betterment of humankind. So our motto is, if you're not sure it can work, bring it to Elcon, we're ready to find out. So let's talk about micro and nano satellites. This is an image of NASA's Cygnus, the Global Cyclone Navigation Satellite, which is just a beautiful piece of technology, an example of a low orbit satellite that does imaging of the planet Earth for weather. Now, what are microsatellites used for? And I have a series of examples here. They predict weather, hurricane, terrain mappings, changing sea levels, telecom, as it was mentioned by Mr. Dittenruge, that they can be used for communication, imaging, defense, astronomy. And actually, they're used to examine, like the Hubble telescope or these modern telescopes that are just launched. They look into the sky. They can characterize the sky. They also can look at the sun and characterize the sun and sunspots so we can better understand the source of the pretty much the energy of the whole universe, or at least our planet, is the sun. So satellites, what's the great thing about technology is satellites can become smaller and smaller. So when you look at payload launches for Falcon and the SpaceX basically launch systems is all based on per kilo. So the more you can pack into a kilogram of weight, or 5 or 6 kilos or 10 kilos, the more value you get from a launch. And so microsatellites really allow kind of a budget, low budget or lower budget way of actually getting experiments done in space and providing, launching something into space. So they're small. The launch vehicles are now reusable, and we've seen that on the internet, and even Blue Origin and SpaceX having reusable launch vehicles with thrusters, so it reduces a lot of cost. It's possible to launch hundreds of these devices in a large payload launch, and even Elon Musk launched a Tesla sports car into the sky, kind of demonstrating the capability, wasteful of energy, in my opinion, to launch a large thing into the space. So it kind of shows you the capability of, if you had a lot of small satellites, you could actually launch them in. So pico satellites, if you look at the bottom diagram here, they're about a kilo, maybe a couple kilos. Nano satellite, and that's like the box satellite. That was a picture in a prior slide. Nano satellites are between 1 to 10 kilos. Microsatellites are considered in the 10 to 100 kilo range, so be kind of a little more expensive to launch. And then we have the small satellites, which are in the 100 to 1,000 kilo range. So it kind of gives you the idea of the type of satellites that in terms of size. So there were some questions from the audience in advance about the size of understanding pico satellite or nano satellite. Of course, you could pack more probably into a nano satellite than a pico satellite. But again, it kind of shows you the range of variety of technologies that with advanced technology, and especially miniaturized manufacturing, we can pack a lot of hardware into a small device. See if I can advance this. Let's see if I can get this here. Yeah, here, okay. Sorry, everybody, I'm just fiddling with my slides. Okay, now micro and nano satellites, understand the microsatellite or microsat is something that's sort of in the 10 to 100 kilo range. And again, it's views pounds, it's 22 to 220 pounds. Nano satellites, which I think the more of the hot thing, and we saw a lot of that at Space Tech Expo, a lot of companies advertising nano satellites. They're in the area of 1 to 10 kilos, like Momentus is a company that offers such a device. They're small, being that they're tiny. You could launch a lot of them, and they're very inexpensive. However, you have to have a lot of miniaturization of technology. So the challenges with these microsatellites is to pack like 10 pounds of hardware into 1 pound vessel, which is the challenge that we have to face. So Elcon Precision, we have mastered a lot of this micro precision manufacturing, and you're going to see that in a little bit about how we actually put together an electronic drive for some of these small vehicles. So some of the challenges that we have for microsatellites and nanosatellite, improving the strength of the integrated design of the circuits, enhancing integration of electronic systems. And the strength issues are not necessarily when it's in space, but when you launch it. The stresses that are encountered by the microsatellite during launches are tremendous. So it has to be durable enough to withstand launch. Once it gets into space, it's not as difficult, but clearly launching uses a lot of energy. It's very rough on the satellite. You have to have highly integrated, reliable components, and you need redundancy. So you can't have just one system on a satellite, say one communication system. You have to have multiple systems. So this, of course, adds weight. So you have to set your priorities on key systems that they're operational, yet you don't want to add a lot of weight. So you also want it has to be durable. So a lot of testing is done prior to launch, where they put them in, and NASA does this, they put it in a chamber and they rattle it around, they shake it around, because you don't want it to be damaged in launch. But once it's up in space, it's actually pretty safe. It's a very secure place for the satellite because it's in vacuum. But again, you don't want it to be, it gets rattled in launching. And then again, redundant circuit design, and also some smarts in terms of thermal management are important too, because you don't want power sources to cool down. What's nice about near Earth satellites is you have a lot of solar power available. So the sun is a great source of energy in terms of electronics and propulsion systems. Whereas as you get in deeper space, you require more advanced energy sources. So then how do you get a satellite into space? And what's wonderful about SpaceX is because of the commercialization of space flight, you now have SpaceX who's producing these tremendous thrusters. So you kind of look at the numbers here. The number of engines here in this Falcon Heavy it has 27 engines with a total of 22.819 kilonewtons of force, or about 5.1 million pound forces of force. So literally, this is a tremendous amount of thrust. It takes all this energy to lift the satellite into space. So it takes a lot of energy, and that's what the main cost is you're burning all this energy to get it into space. Now, how do you position it? This becomes elegant, and power is not necessarily it's not necessarily brute force. It's ion engines. So ion engines and solar sails use solar power to energize atoms, and using momentum transfer, you could propel things. So when you get to geopositioning or once you're into space, it's very easy to steer your satellite with very low energy, and solar energy can actually be used with power conversion to create high voltages to accelerate, again, xenon gas ions, which create this blue glow that you see behind this solar electric in the NASA Dawn spacecraft, which allows it to position itself. So once they're in space and they have the solar panels deployed, they're very easy to move around. And so that's what's great about near Earth systems is you have the sun available, whereas deep space, you don't have that. Okay, so we're talking about near Earth orbit versus launch systems. Of course, surface to orbit propulsion systems are very large, like, 100 meters high and big in diameter and noisy and use a lot of energy. They have thousands of kilonewtons of force. They use a lot of fuel. They have to be aerodynamic because they have to deal with the atmosphere. And there are some questions about hypersonics. And again, the faster you go within the atmosphere, the higher the temperatures that your materials have to handle. So there's a lot of material challenges. So you have to be aerodynamic. You have to be smart with your materials use. Micro and nano satellites, that don't need to be aerodynamic because in a vacuum. So you can have basically a box, doesn't have to be aerodynamic. And you only need enough speed to stay into orbit because you want to have a stable orbit around the planet, and you have to be able to withstand a long time. So you need low power usage, solar powers, and then again, solar winds are good for that, or low power ion engines. So where do satellites travel after deployment? This is a very great diagram, and this is something that perhaps folks will want to spend some time to look at. There's a lot of information in this diagram, is that small satellites need to be in a stable orbit. So you can see from the diagram that the orbits can range from, they're thousands of miles, 30,000 kilometers. So most the satellites, Iridium in Hubble, you see it closer to the planet Earth. You can see GPS satellites are located farther out, maybe about 30,000 kilometers with orbit frequencies of 10 hours. So this diagram shows you that basically the farther out you get, the less speed you require to have a stable orbit, because it's centripetal force. So as you get closer to Earth, the forces are much greater. So you have to have a higher angular velocity to maintain a stable orbit. The farther out you get, it's easier. You don't have to be as fast. But however, if you want to map the Earth or take pictures of the surface of the Earth, you got to be close into the Earth. So that means you have to travel fast. And so like Hubble telescope is positioned pretty close to the planet Earth. You can see some other positions here. So this is a great diagram that understands that, the other thing that's cool about this information is that the orbital frequency, that the Hubble telescope probably has like maybe a 6 to 7 hour orbital frequency, which is really short, whereas the GPS satellites maybe about 10 hours. So, but that means probably during the day, the GPS satellites are passing over your location on the planet at least twice, which is very interesting how they're positioned. So this is a great diagram that kind of shows the ins and outs of speed and elevation and position from the Earth. And it really depends on what you want to do. If you want to take pictures of the Earth, you probably want to be close. If you want to be looking towards the stars, maybe farther, or you want to be in a low energy stable orbit, probably closer to the GPS satellite orbit. So again, electronic propulsion systems are great for this. They can achieve velocities of 400,000 kilometers per hour using ion engines. So no problem with these velocities. So electronic propulsion systems like ion engines are great. Altitudes are from 90 kilometers to 30,000 kilometers, and speeds easily ranging from 11,000 to 30,000 kilometers. And again, these are very capable for solar winds or for ion engines. Now here's a little bit about ion engines. So at Elcon, for the NASA DART mission, we supplied major components for the ion engines. We've also done ion engines for other companies like Momentus. An ion engine is a momentum transfer engine. So you take some heavy atoms like xenon, and then you accelerate them using high voltages, and you have to ionize them. So you ionize them, which you have a lot of energy and some magnetic fields that actually makes the xenon atoms kind of light up. You got to basically ionize them. And then under high voltages, you shoot them out at the end of the gun. Now this creates, since xenon is pretty heavy, it creates a large amount of a momentum transfer. So it allows these ions, even though it's not like a huge amount of thrust, it's a very continuous amount of thrust as you slowly leak them into the ion engine, and you're all in a vacuum here and use these grids to accelerate. These devices can achieve, again, velocities of much over 100,000 kilometers per hour. So again, a very, very simple, elegant way, no moving parts, which is very important for space. Less moving parts, more reliable. More moving parts, more things to break. So again, electronic propulsion systems have no moving parts. So this is an example of an ion engine. So that lets you folks know. And again, it's using xenon, an electron gun that feeds it. And then you'll see just very quickly, Rebecca is going to show you how to make the core source of an ion engine. So just kind of a bigger thing of ion engines. Yeah, they're great. If you're close to the planet Earth, they work great. You could use solar power. As you get farther from Earth, you need to use different sources like nuclear power. Nuclear power is great until you get to about Uranus, and then it's too cold because you need to have working fluid for nuclear power. So radioisotopes are what you use to power very, very deep space ion engines. So they're typically radioactive materials like cesium-135 that decay. And then that actually creates the energy. They're slower, more hazardous to launch. But again, it kind of shows you the range here of how ion engines can really help you propel your small device great distances. Definitely much easier close to the planet Earth. So summary of electronic propulsion systems. We got these big launch systems like Falcon Heavy that launch these things into space. It's a lot of energy. That's where the most of the cost is. Once you get into space, they're amazingly compact and they're clever. You have solar panels that are high efficiency that deploy. You can use solar sails, ion engines. These micro and nano satellites have very few moving parts, and that's important because you need reliability and redundant systems. They have to be reliable. You really can't repair it. Once it's out there and it breaks, it's space junk, you know, so maybe you can recover it, but again, hopefully we don't have to deal with a lot of those. But again, that's the problem with these devices. They don't have any ability to repair them. They have to be durable for long life, and they really have to be made from materials that are kind of readily available on Earth. So again, NASA and working with NextC, the ion engine, they've come up with some great products, and Momentous Aerospace, a lot of companies. Again, ion engines are really now, I think, a thing of the now, and really important for microsatellites. So I just want to give a quick kind of shout out to some of our Elcon missions so you guys understand what we've done. We've done NASA Solar Explorer sunspot grading. This is a tungsten component which is used to characterize solar radiation. It's been used to actually characterize the sun in very detail in terms of alpha radiation, which is important for Artemis. Artemis, one of the largest risks of the Artemis moon mission is alpha radiation on the moon. There's no way to protect yourself from it other than ideally water. Water is a fantastic alpha radiation protection device. If you can get water on the moon, pump it to some locations, it actually can protect you. So again, we've done Artemis, we've done this NASA Solar Explorer. NASA DART, I just talked about it, it launches tonight, which is phenomenal. NASA's first planetary defense mission using NextC ion engine to propel this device, supposed to be around 20,000 kilometers per hour into Didymos Prime to dislodge its orbit. So we can actually confirm or prove that humankind can be saved if an asteroid's coming towards us, we could displace it. So again, really big deal. And at Elcon, we also done the launch systems at Vandenberg, very important. So again, phenomenal work from the team and also with NASA to do this. And so it's an exciting night as that thing launches tonight. SpaceX Starlink, we have devices in Starlink. There's going to be 42,000 satellites for Starlink. I think it was about 8,000 now. So we have components in the Starlink system for telecom. It's another wonderful product that will bring internet to everybody. I mean, it's going to cost money, I guess, because it's Elon Musk, but generally, this is a way that we can globally become connected. So you can basically get your 5G signal any place on the planet. Again, thanks to SpaceX. And then now I want to transfer the talk over. I'm going to basically introduce Rebecca Salcedo from Elcon. So she's going to go ahead and present the next section of the talk here.
All right, hello, I will be presenting how to build an ion source for a micro and nano satellite, just some of the processes that we do here at Elcon.
కాదు కిటికీ హే GPS చెప్తాకి
Okay, thank you. All right, so right here is a example of a ion source. It's an assembly that's made up of 3 sapphire rods and 5 molybdenum grids. 3 of them which are photochemically etched in-house here at Elcon, and then 2 that are precision machined out of house. And then there's also 3 Kovar lakes. The total assembly in height is about 1/4 inch, so about 19 millimeters. The sapphires in diameter are about 40 mils, which is about 1.016 millimeters. And it's a very, the grids range from about 10 mils in thickness to 35 mils in thickness. So very small components here. So here is just an example of the metallization process flow. So for those who may not know, in order to bond a sapphire or ceramic to metals, you can either use an active brazed metal, or you can do what we do here at Elcon, which is a moly-manganese paint. And these sapphire rods are actually hand painted with this moly-manganese paint. And we use Camco furnaces, which are cold wall style chambers with moly heat zones with ceramic elements. They can operate with pure hydrogen or a mixed atmosphere of hydrogen and nitrogen. And the process gases can go through a water-filled bubbler to humidify the gas for processes requiring a reducing atmosphere. And the chemistry for our metallization needs that reducing atmosphere. So then from there, we go into this assembly process flow. So just basic, everything needs a work order here. Then stockroom will pull our kit, which again are all these components you see here. Then they would move it to the assembly where, we have to have the correct fixturing, because we're brazing at high temperature. These are brazed around 900 degrees C. So we use ceramic bases, which are very similar CTE, your coefficient of thermal expansion, to your Kovar. So everything will be expanding there around the same rate. And then we use ceramic spacers between the moly grids, because again, it's a high tolerance part where you need about a 60 mil plus or minus 2 mils, which is about 1.524 millimeters plus or minus 0.05 millimeters, spacing between each grid. And then there's also a high tolerance of a true position between the IDs for each, which we use that indexing moly pin. So the ones there all assembled up like that indexing pin will help keep our true position. Everything needs to be really straight, again, to hit those really tight true positions at the end. And then if you can see in the picture to the far right, there's a 5 mil spacing between the first and second grid that needs to be met. And then they'll go through our inspection process, and then these parts will be count and packaged and shipped to our customer. Just to do a quick little conclusion there, Elcon specializes in ceramic and sapphire metallization and the joining of alumina to metal components with our advanced brazing capabilities, which make us a notable supplier to the space industry. Personally, here at Elcon, I have helped the qualification process that led to Elcon producing key components for the DART program, as Tim has stated, and I've also brazed metal-to-metal components for space infrastructure.
Great. Well, thank you, Rebecca, for that. And Rebecca has been a great resource at Elcon. And honestly, the most important thing in space technology is the people that make things, and the people that design the components, and the people that make it possible. Really, when it comes to like companies like Elcon or SpaceX, you know, the human resources are the most important thing, because you can't do something without smart people. So I just want to give again, a shout out to the space industry. If you want a career in space, it's a growing industry. It's with microsatellites and with the commercialization of space, in addition with agencies like for governments, but also now you have these private companies that are, or public companies that are actually creating technology. There's a lot of opportunities in space. So I'm a big proponent of science, technology, engineering, math, education, and in applying that to really helping us explore space. So this is some work that was done by one of our business development people, looking at the job growth between 21 and 29 of astronomers, aerospace engineers, physicists. You know, there's actually technical writing and people involved with the information, handling the information that's about space, robotics, astrobiologists, astronauts. And if you're lucky, the next generation, not mine, but your generation may actually be able to go to Mars, because we're going to be pretty old, but I guess, you know, the younger folks out there will probably be young enough to make it to Mars. So there could be really great opportunities in the next couple of generations to do some phenomenal work in space. So I think this is a great career. And so there's a lot of companies that are developing in space coming up. So please consider space technology or manufacturing or design of space components as a career element. So I think you can advance the slide, Nikki. Now it's all about people. So I thought it would be good in this case is to introduce myself and some of my people, and we're going to talk about working in the space industry, because it's very rare that folks get an opportunity to actually understand the people that make things in space. And I want to introduce some folks. So first I'll introduce myself. I'm Tim Dyer. I'm a California native that was educated here in California. My mother is German, 100% German. So I'm a German American, and I grew up in the United States. I decided to become a material scientist after starting a degree in mechanical engineering, because I discovered material science and I thought it was wonderful. It's great to see how metals and the modern day blacksmith, it's great to understand how materials are so important for success of a design. I got a bachelor's and master's degree in engineering from UC Davis. UC system in California is a great place to get an education. I've worked in Elcon for 7 years. Assumed the role of general manager in 27, but I'm a scientist. I'm not an MBA. I'm an engineer. And so I'm really happy with the folks that we got and a strong team we put together. My hobbies are mountain biking, yoga, traveling, and I like wine making. And I'm a bad winemaker. And then when I was young, I used to play in a band. So that's what I did. So this introduced myself. So I think I'll hand it off to the next person, which I think is Rebecca.
I'm Rebecca. I was born and raised here in San Jose, California. I am Mexican American. I got my bachelor's in industrial engineering from Cal Poly, which is a state university in the Central Coast in San Luis Obispo. What is industrial engineering? It is a engineering manufacturing optimization of complex processes, systems, or organizations. Why did I pick engineering? I love math. As a kid, I loved playing video games and science projects. I was a part of the Mesa School program that serves educationally disadvantaged students, and it helped me prepare for college and led the way for me to become a first-generation college graduate. I've been here at Elcon for 5 years, and some of my hobbies include hiking, cooking, video games, traveling, and spending time with family and friends.
And I'm Nikki, the marketing and sales analyst. For the past 2 webinars, I've been kind of like the man behind the curtain, you know, managing the chat and putting up the slides. And a little bit about me. I was born and raised in San Jose, California as well. My parents are both Vietnamese immigrants. And then my educational background, I do have a Bachelor's of Science in Bioinformatics from the University of California, San Diego. And bioinformatics is kind of a merge between, or merge of computer science and statistics to solve biological genetic problems. So I'm basically using computer science skills and knowledge to apply it to solving gene problems or gene mutations and whatnot. And I enjoy bridging multiple disciplines together. So Elcon offers just that because I'm the marketing and sales analyst. So I get to do a lot of research between different markets and also look at the data and then work between different teams in the company. In my free time, I like to read, play the guitar, play spike ball, and do lots of learning.
Well, thank you for your introduction. So I thought what we do, and we're open to people typing in questions into the general chat, so we can actually process that. You have an opportunity to talk to a few people who work in the space industry as engineers and scientists and contributors. So, but I'm going to start out with asking a few basic questions about, let's say, Rebecca, just to help us understand who you are. When you were younger, what did you want to be when you grew up? What was your inspiration for your schooling, or what inspired you?
Say if we go back to elementary school, I wanted to become a teacher. And I think that was just because I enjoyed school and learning. As I got older, I thought I wanted to go more into like biology. Then I realized, no, I like more like math and physics. So then that's where I decided to go into engineering. I actually went into Cal Poly as a general engineer. And there was, after my first year, it was, okay, do I stay in engineering or do I just go straight into math, become a math major? But I ended up choosing industrial engineering because I was intrigued about how it branched business with the engineering world, how to draw upon statistical processes to evolve management control systems, to assist in financial planning, cost analysis, production planning, and physical distributions of resources and goods. It's all about continuous improvement.
Wow, that's great. I mean, you've done some fantastic work. And I'm Nikki, I'm curious of the same information, same question. When you were young, did you imagine yourself doing this, or was it very different? Or
Definitely not. I mean, when you're younger, you kind of, your career choices are limited to like what you see on TV and to those that, you know, around you. And so, I mean, I remember I wanted to be a teacher as well because my teachers were awesome and I enjoyed learning as well. But I also remember watching a lot of like home remodeling TV shows. So I wanted to become an interior designer. Obviously, I'm neither of those. But my career, I developed a love for science as well. So therefore, I majored in bioinformatics, and then from there, I just branched off.
I have a question for Rebecca. What were some of the challenges you had when you first started working? How did you get a job? I mean, can you explain some of your challenges?
Yeah, it's very challenging coming out of college and trying to find a job. I did receive an internship when I was in college. It's all about perseverance. My school had college fairs, which were great for interviewing. But ultimately, you know, being from the Bay Area really helps with the networking and yeah. But I ended up getting my job here at Elcon through LinkedIn.
No, it's great. Well, we definitely were very happy to find you. I have a question for Nikki. Is what type of skills and abilities would help a person be successful in your role at Elcon?
Yeah, I think having the drive to learn and be curious is important because there's always something that you can do better, especially for me in the sales and marketing efforts. I'm always online learning and about different markets and how we can better reach out to them. And I've noticed, not even within my career, but every other person's career as well, like you, Rebecca, right? Like you're always learning new ways and about new materials and stuff. So yeah, drive to learn and be curious. Definitely.
And then one last question before we transition to the technical Q&A. So folks, get ready that we'll have a technical Q&A. This is to Rebecca. What advice would you give a student interested in this type of career?
I would say that you have to have, and with my career as far as process engineering, that you would have to have interest in project management. We are, an engineer to order company, so we receive many engineering drawings to unique products, and we need to understand the engineering requirements and provide feedback to manufacture the design correctly. So you have to have interest in seeing a project from start to finish to help with process management, the analysis of the process, model or plan the process, develop the process, and also test and troubleshoot. So really being flexible on, things can go wrong, and you just have to put on different hats and try and solve them. And, that sort of goes back to the whole, scientific, I can't think of the word right now, but
Scientific process.
Scientific process, there you go.
No, that's great. And the only thing I could say about me is I've always been curious, and it's good to have energy and curiosity and never stop learning. So my advice to any of you folks out there engineering is that want to get into this is do it because you like to do it. Do it because it makes you excited. Don't do it because you want to make money. Really, you want to do it because you have a passion for it. And that's a lot of us at Elcon. We do this because we want to make an impact. We want to really help things. And also there's a lot of personal satisfaction in making something that someone said is impossible. Nothing's more satisfying to me than saying it's not possible and you can make it happen. So again, thank you, Nikki, and thank you, Rebecca, for your contribution. I think we roll on to the technical Q&A section.
All right, let me stop my share so I can see the chat. So right now, I don't see any questions yet.
Well, we have some questions that you prepared for the advanced submissions, right?
Yes, I just wanted to check the chat real quick. Actually, there is one question before I move on to some prepared questions. What is wet mass? I think it was mentioned in one of your beginning slides.
Wet mass, that was probably the mass of something before the fuel is spent, because that would be it weighs more before it takes off. So that's the mass of something before its fuel is spent.
All right, I don't see any other questions yet. Y'all can keep submitting them, but in the meantime, we do have some questions regarding material. So what materials are used in very cold and very hot conditions?
I'll take that one.
Yeah.
So molyrhenium, so the rhenium to the moly improves plasticity and wettability and decreases brittleness for certain temperature ranges. Hafnium is found to be a particular effective high temperature strengthener. Tungsten is used to make rocket engines, nozzles. Invar and other nickel iron alloys are used for aircraft instruments and precision composite molds. So there's some materials.
Yeah, I could chime in on the cold materials, and I'm not sure if there's many material scientists out there, but certain crystal structures are more durable in cold climates. Those being the face center cubic and the hexagonal structures. So this kind of limits you to titanium. Like you could use stainless steels that are like the austenitic stainless steels are good. Moly is very good, though it does have a ductile brittle transition. It can be brittle at low temperatures. It's relatively durable. It doesn't crack. But the big problem with cold materials is polymers don't really handle the cold. They're very brittle and they can crack. They're not durable. You really have to stick to ceramics, which are pretty much consistent over a wide temperature range. So that's why we see a lot of ceramics used, because they can run from minus 260 Kelvin to plus 2000 Kelvin. So they're very good. One of the most marvelous materials for space components is graphite or carbon. Believe it or not, carbon, since there's no oxygen in space, it doesn't burn, and it has low expansion coefficient, so it's very stable. It is pretty durable. Even though you think about like a pencil, like the pencil, writing with graphite itself is a very, very good material. It's lightweight and fantastic for space components. So being able to handle cold temperatures to very high temperatures, not being too expensive, it's easy to fabricate with too. So we're talking pretty basic stuff like aluminum foil. Aluminum is also good at wide temperature ranges, doesn't have any ductility issues. So thin aluminum metal, graphite, very basic things. But these are things that are also could be available if you're building something on like Artemis, a moon base, where you don't have a tremendous amount of resources available. Carbon's usually pretty available, and there's actually aluminum on the moon as well. So that could be used to construct things. So I guess that kind of covers that question. I think there's some other stuff. So
yeah. So you talked about a lot about like high temperature materials and lightweight materials. What other materials are efficient and lightweight for aircraft, do you think, Becca?
I would say like aluminum or titanium is materials that are used, that are lightweight and strong and reliable, like extreme pressures and the high heat and the dramatic shift in temperature.
Yeah. All right, let's move on to another question under materials. What is the recent status of material development for thermal protection systems of hypersonic space vehicles?
Well, I was hoping that Scott McCormick would be on the line from UC Davis, because I don't know if Scott's there, if he can chime in or something or say something. But Scott is an expert on hypersonic materials, and I met with him just about a month ago at a UC Davis meeting, where he's working on measuring material temperatures in the 4,000 to 5,000 Kelvin. Hypersonic vehicles, because of the wind or the amount of energy that's imparted on it, will create very high temperatures. So right now, the biggest challenges that he's finding, and if he chimes in, it'd be great, but other than that, that it's measuring the temperatures at 4,000 Kelvin is very challenging to be able to do that accurately. And also the reflectivity or emissivity materials is a strong function of temperature when you get up to around 3,000 to 4,000 K. So this means that hypersonic materials will be, it's very difficult to characterize them. In addition, they have to handle high temperatures. So the high temperatures being above 2000 C to maybe 3000 centigrade, a lot of them are oxide ceramics. I know of one particular system, which is yttria magnesia, which is potential for an optical sensor material. And there was some work done by Dr. Mukherjee at UC Davis, was taken over by Dr. McCormick in his hypersonic development. And some of it's this spark plasma synthesized materials coming from UC Davis. There's also work done in just generally forming or joining the materials, because in hypersonics you have there's a couple ways of dissipating heat. You could take a material and have it burn, and that actually would dissipate heat by phase transformation. So like say you want it to evaporate or boil off. That's one way of managing heat. The other way is to have a high thermal conductivity material that you could water jacket behind, and then you could pump some sort of coolant or maybe an organic material behind it to transfer heat. That's another type of strategy for hypersonics, is whether you want to go for a thermal conductive material that you can pull the heat away from, or you just go for something that can handle really high temperatures and then actually not burn up. So again, Scott is a guy at UC Davis, and he's actually a professor from Australia. You might want to look him up. Is doing a lot of work with these high temperature ceramics and composites in the area of hypersonics. So again, but I don't think he's around, but I did send him a shout out.
Yeah, I don't see Scott in the chat, but
yeah, it's a shame that I sent him a shout out, because he's actually one of the world's experts, and it's a pretty new field. A lot of the research is classified. It is kind of military. But if anyone else out there has some input, I see some questions here though.
Yeah, so I see in the chat there's a question from Ivan. For PCBs used in satellites, are electrical properties like conductance of the traces similar as on Earth? Does current flow in the same way under zero gravity? If not, then how do you design and simulate PCBs for conditions in space?
Well, I don't know if Ed wants someone else. I could handle this. Is that we make a lot of guidance boards, the Elcon, for high-speed vehicles and for space, and the Ohm's law does apply to space, so there's no influence of space and Ohm's law. You do have radiation problems, so you can, because you're not within the atmosphere of the planet, you can get alpha radiation, which could cause like charge migration. So radiation hardening is something to consider when you're making PCB boards that go into space. But the conductances are very similar, so that's actually very helpful. Actually, even better probably because they're colder, and we all know that electrical conductivity with metals tends to improve as you get them colder. They tend to be a little better. So current does play this, and gravity doesn't play an influence in that, which is good. So you don't have to have that complicated design. I think one thing that becomes very important in space is, again, radiation hardening, or the ability of a material to withstand gamma or alpha radiation from the sun, so that you don't have any additional electronic currents that you weren't planning on. Because that's one thing on Earth is we're lucky we have an ionosphere. We have protects us from that. So thank you for the question.
Yeah, we have another question. Says, please mention the cost involved in micro nano satellites.
Good question. I'm trying to think of I think the ion sources we sell around, it's like $400 or something for that. I mean, just kind of, I think it's roughly to give an idea of a single component. So if you're looking at the cost to build a device, you're probably in the, I'd say probably $10,000 to $20,000 range to construct like a box. The main cost is getting it into space. It's like freight cost. When I was young and I used to write letters to my grandparents in Germany, I would write these thin little envelopes, these airmail envelopes. So it's like the paper was like really nanogram type paper, and we would send that. And it's almost like it was not necessarily the cost of the paper; it was the cost of the transport or getting the letter to Europe or whatever. In those days, was a big cost. So, and the costs they're kind of in the tens of thousands of dollars per kilo type cost. So your device may cost $20,000 to construct. It could cost you, $50,000 to $100,000 to launch it into space. That's the advantage of these micro satellites or nano satellites, is you're not paying such a tremendous amount of money to launch your experiment. So a country could definitely afford to launch these. I mean, it's something that I think as normal, people like me, I couldn't afford something like that. But again, if you have a country or a large company, it would be very affordable to launch something like that if it was small.
Mm-hmm. Okay, well,
if I can butt in real quick here. This is Ed. So when SpaceX puts up their satellites, you can actually watch videos of the launch, and in the space of something like 45 minutes, they'll distribute 60 to 100 satellites in space on a single launch. So, like Tim said, the real cost, most expensive cost, is getting it up in space. So the more satellites you can deploy in one launch, the better. And it's like magic watching these satellites just drop out of the spaceship, and when it's done, it just returns to Earth. So it's a really fascinating, inexpensive process to get satellites up there.
Mm-hmm. Thank you, Ed. So speaking of satellites in space and after deployment, what happens to the satellite? Another question that we received in past webinars is, what happens to the satellite after its service term is completed? Rebecca, you want to take that?
Yeah, so for closer satellites, they'll fall out of orbit and they'll burn up in the atmosphere. For further satellites, they're just pushed further away from Earth.
Oh, cool.
And it's actually a good question. It's from Anil, and he says that can satellites stay in orbit forever? Not possible, because you have to keep up that angular momentum. So as you soften the diagram, it has to maintain a certain amount of speed. If the speed decays, it'll actually fall into the planet. Or if it's too fast, it flies away from the planet, as Rebecca said. So, I mean, it could be many years before it starts to decay, but eventually a close Earth satellite, which has to travel really fast, like 20,000 kilometers per hour, once its speed decays, it does start getting close to Earth, and then once it gets close to the atmosphere, it burns up. So what's great about nano satellites is we don't have to worry about the Skylab thing where you have a big piece of equipment falling from the sky like a ball of fire. I mean, if you're looking at 1 to 5 kilogram object that enters the Earth's atmosphere at 20,000 kilometers per hour, it's probably not going to last very long. It'll vaporize, so we won't have to worry about it. There are some fears I call space junk, where maybe if there's enough stuff out there that they may start colliding with each other. But you got to remember, the volume of space as you get farther from the planet is huge. So the cubic meters of space as you get maybe 1,000 to 2,000 kilometers from the surface of the planet is huge. So the odds of things colliding are pretty low. But eventually, you know, with Starlink and 40,000 satellites out there, there might be some chances of some collisions. But again, that's because of the I call the entropy effect. There's enough disorder out there where we shouldn't have collisions. But eventually, over time, they'll either fly away, as Rebecca said, or they'll fall into the planet and become a beautiful shooting star. So we can watch that.
Yes, that's what
One more thing to add from me. Sorry to butt in.
Thanks, Ed.
There's also a kind of an international agreement to keep track of everything in space. So you just can't, and there's a question that kind of relates to this. You can't just willy-nilly put up a bunch of satellites and have it be okay. There's general agreements on where and how many satellites you can put up into space. And when you do have satellites go bad or they turn into junk up there, they need to be tracked so that things like the space station can take evasive action if a big chunk is coming at them. And I think it was the Russians just recently destroyed one of their satellites and got into a little scuffle with the international folks that they put all this debris out there. And I don't know which satellite or if it was a space station did have to take some evasive action against one of these big chunks flying out there. So there's a general agreement to control this, but you know, let's just hope it stays that way. There's plenty of room up there, but you still have to be careful about what kind of junk you put up there.
Thanks,
Speaking
Ed.
of other space junk, what happens to the, you know, when you launch the satellites, you have the fuel tanks and rocket boosters for the spacecraft. What happens to them after launch?
So in the original NASA launches, they would just drop to Earth and they would launch over the ocean. So they would just land in the ocean and pretty much sink. And then really SpaceX was the innovator here, where they unbelievably found a way to bring back that first stage to Earth and land it on a platform. And I think they have it nailed now. I don't think they ever have failures. But the further up in space you go, as those pieces fall out, the tanks and first and second and third stages, they'll burn up in the atmosphere. But the biggest change in terms of economics has been SpaceX figuring out how you can launch it and flip the first stage in space and then have it land safely down on Earth. And I've been lucky enough to be on the SpaceX production floor a few times, and I've actually seen these first stages when they've returned. They were sitting on the production floor, and they're kind of dirty and burned up, but it's just amazing to see these things that were in space and then were recovered. And I also got to see a lot of those engines that they were building, as well as the docking station for ISS. So it was a real treat and a real honor to be able to walk around on the production floor at SpaceX.
Can you describe how big those are, Ed, just so people in the audience understand how big these components are?
The first stage that they recover it's got to be 20 feet in diameter and probably a couple 100 feet long, be my guess. I mean, easily 2-3 people can stand on top of each other on the inside diameter of these things. And then the rockets, at least the ones being built that I saw, they were maybe 6 to 8 feet tall, each of them. So pretty big stuff, and probably 3-4 feet in diameter. But like you showed in your picture, there's 27 of these on the Falcon Heavy. It's just I'm just in awe of what I saw there and what SpaceX has been able to do. It's just amazing.
Yeah.
We have an interesting question about job opportunities. I'm not sure if you want to talk a little bit more about. I could actually say about Elcon Precision is that we do hire college interns, and a lot of companies do this. It's a great opportunity, like what Rebecca and Nikki. That's how Rebecca got her, I guess, cut her teeth, is on college internships. Is that we do a lot of companies have internships. You just have to contact folks like myself, or again, LinkedIn is great. Resource for networking. Networking is a great way to get a hold of folks for job opportunities. I don't know, Rebecca, you want to talk about how networking helped you in your job opportunities?
Knowing the right people, I guess, helped me a lot. I had a friend's a friend that got me an internship in Fremont at a small global supply chain company. So that was my first industry. And then even after college, I was working there before I moved to Elcon.
Yeah, I was a new college graduate at Applied Materials, so I actually got a job out of UC Davis working at Applied Materials, which is a semiconductor equipment company. But there's a new college graduate program, so those are other ways you can get involved. It's like an internship that becomes a permanent job. So that's another way of getting in. So again, there's opportunities out there. I think it takes to have faith in yourself that your skills are useful, and folks will be out there. It is both, remember, both sides. The company's looking for the right person. You're looking for the right company. So it's a matchmaking. So not every company is a good fit, and you don't necessarily want to be at a company that's not a good fit. That's what my recommendation is. You want to find a company that fits your spirit and what you want to do, captures your ambitions. And so that takes a while. So be patient with job searching in general, and you'll find the right place. And then once you find the right place, you want to learn. So as long as you're learning, it's great. I see another one is
another question on ion engines, actually, from Ivan. In ion engines, do you use ion gas or xenon isotopes for ion production? If so, what isotopes do you use, and what mechanism is used to dislodge the electrons from the orbitals to produce ions?
Well, we use xenon gas as straight out xenon. There's no isotope, different isotope, but you got to have enough energy to take electrons off of it. What's great about xenon, and I've used a lot of inert gas, high energy inert gas, is you can actually strip multiple electrons. So if you look at xenon, and I don't want to bore people, but you have multiple charge states. So you have xenon +1, +2, +3, +4, +5, +6, +7. So if you look at the acceleration voltage on a xenon ion, once you use an electromagnetic field to shake off that electron or those electrons, if you apply a high voltage field, like a 20,000 volt field, a xenon +7 would be 7 times 20 kV. So you could basically have huge multiples. And so what's nice about xenon with multiple ionization states is having enough energy to pull off the electrons. You can create huge acceleration potential. And I've seen, especially with krypton and xenon, I've seen tungsten materials completely ablated away rapidly within nanoseconds by the amount of energy that you can impart. Like a 5 joule pulse of xenon +7 at 20 kV will vaporize like a 1 centimeter diameter piece of tungsten. I mean, it's literally amazing amount of energy. So xenon is great for ion engine because it's easy to shake off electrons, so you can create high ionization states, which allow for great acceleration potential, which means you can create huge momentum for acceleration. So, but it's straight out xenon gas.
Thank you, Tim. Another question in the chat, can a computer programmer get into space industries? I mean, I can take this one since I do.
Why don't you do that, yeah.
Yeah, I do have a slight background in computer science. In space particularly, I mean, if you take a look at the Mars rovers, those are all automated by code. And thousands of lines of code, run those satellites and those robots. And then in automation, robots, you need lines of code to run that. You need computer programmers. And then for me personally, I did take some computer science courses, and here at Elcon, I don't specifically apply that, but there are concepts that I have learned that have been applied, like automating data analysis, and even in creating the website, you have to fix certain things. There are certain bugs that you have to go and look into. There's no question in the chat. While manufacturing microsatellites, were the carbides used? I'm not sure.
Yeah, you talk about silicon carbide, or it's kind of like a rich man's graphite. Silicon carbide is a very stable. I'm assuming that's what they mean by carbide. Tungsten carbide would be kind of a hard and heavy material, but silicon carbides are pretty lightweight and they're very stable. I'm not sure. Again, the clarification of the question is whether versus graphite in the application. Is this for this Surathra, this college, is whether he means, is it comparing graphite to silicon carbide, or is he talking about, because carbides, they're great for hardness and durability, but and they're great for oxidation if air is present, because silicon carbides, when they oxidize in the presence of air, they form silicon dioxide, which is quartz, which is good for passivating, but in space there's vacuum. So unless he's talking about a fiber reinforcement, like maybe if it's aluminum oxide with a silicon carbide whisker reinforcement. So I need a little clarification on that, because graphite is a pretty inexpensive and pretty much works in general. Though I think SiC could work if you needed something. Maybe it's something that's can withstand a whole bunch of heat with atmosphere present. I think we're getting kind of close on time, because I think that the last 10 minutes is, I think DB want to do concluding remarks. So I'm not sure, DB, if you want to take it from now.
Yes.
This has been wonderful. I'm really think this is great.
Yes, Tim, thanks for that. There's a very interesting question on computer programmers. We were talking to one space industry expert, where they said that there is a lot of demand, there is a lot of use for youth with skills in C language and in Python language. The inputs that we got from the space industry expert was this: there's a lot of demand for youth or for college students who develop their skills in the C language and then in Python language. There was a particular question from one Mr. Arvind Kumar on, can a computer programmer get into space industries? So with that, ladies and gentlemen, this has been a wonderful third edition. I would like to convey our sincere thanks first to our Consul General, sir. Consul General, sir, would you like to give your remarks, please? As we come to the close of this session, can we request Mr. Nitirush Phone Prasad, Consul General, sir, can we request for your remarks, please? Yeah, as we wait for that, I would also like to convey our best and sincere thanks. This is the Thanksgiving Day week in the United States of America. So this has been very kind of Tim and his wonderful team that they took time out to do this. There are large groups of college students attending this particular program from PSCMR College, Vijayawada, from Saurashtra College, Madurai, and Acharya College, Pondicherry. So these young engineers, young science graduates are really enthusiastic about what space industry is all about. And I'm sure as we continue to do this series, we are going to have a definite impact on the way that they are going to plan their career. So on behalf of Explore the Space and Elcon Precision, our sincere thanks to the Consul General Thailand, Mr. Nitirush Phone Prasad. Our sincere thanks to all the faculty members and students who are very enthusiastically participating in this particular program. We will be having the 4th edition of the webinar series sometime in mid-February. So please keep watching, and we will be very soon sharing the YouTube version of this wonderful webinar. So those of you who have not been able to join today will have the opportunity of seeing the YouTube version. We have Consul General Sir now. Can we request the final remarks from Consul General Sir?
Well, it's an honor to be here in this webinar. I think it is a very useful forum for participants, and hope that this will continue again in the near future.
Sure. Thank you. Thank you so much, Consul General Sir. We look forward to working with the Thailand space industry. And again, on behalf of Explore the Space and Elcon Precision, sincere thanks to you. And as we say, good evening and good night to our friends in the US. We start our day in India. Thank you all.
Thank you. Happy Thanksgiving. I mean, we're not US thing, but thank you, everybody.
Thank you.
Events like this are really wonderful. It's really hard to replicate the serendipitous nature of bumping into people and the chance encounters, and that's really been my experience as far as I've seen some great people.
It's great to get back to a live conference again, meet with colleagues and chat, see some of the exhibit booths. Very, very fascinating work going on right now. This conference is really unique in terms of having both breadth and depth of knowledge.
Space Expo experience this year has been pretty incredible for me. I just came off a panel, and it was an all-women panel. So how's that for diversity? It's really interesting and encouraging today to see collaboration happening across civil, across government, across the industry, and see new industry participants coming to bear from the